So one of the things that if you're new working with me, the university requires us to record attendance. And I normally do it in this manner where I capture the participants list. The dynamic is going to work a little differently this semester because we are working in-person classes. Each classroom on each campus will have a whole class video camera and microphone. And if you are there and the only thing you have is old school paper and pencil, the only thing you need to do when you see me doing this kind of stuff on screen is mention, oh, you're also in the class, so that when I save this, see, I'm going to save this as, I'll run to the class and then I'll say, let's say 16 August, right? So I'd add someone's name here if they were in the class physically, but not showing on the participants list. And that way I can make sure that I've captured everybody's participation regardless of how they present in the classroom. Are there any questions about how we're working attendance? So once a week I pull up the attendance roster, and what I'll do is use this feature, but I'm not going to spend a lot of, except for today, I'm not going to spend a lot of time doing this in class. Sometimes it's good to pull this up because now Milan was in the mix, right? You're there? Yeah, you're there. I see you, Milan. Sometimes it's really good to, oh, I got to save the changes. It's good to see what's going on here in the first day or so of class. One thing I've discovered is that we have 13 students in the class. However, I'm not sure we have 12 people in this list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the roster may not reflect everybody in the Bucks Connect system, even though online in Blackboard, in Blackboard, we've got a full roster. So I've seen Courtney, I've seen Kevin, I've seen Emmanuel. Let's see who else. Courtney, Kevin. I don't. Oh, hold on. Oh. Where's Omeyer? There you are. I think James was absent, but he sent something about it's a work training thing, right? So it's really good for folks to send points of interest about their ability to participate, because I can check a box where it says excused, right? And I wanted each of you to know that if you hadn't been with me in a class before, I don't grade attendance, I grade participation. And attendance is one of the ways that you can participate in class. So if you're faithful with your attendance, you'll receive full credit for the course. But there are other ways to participate in the course. If you can't be there in person because you have a work shift or personal obligations with your family and you share transportation, whatever, those things are realities of life. And one of the things we want to do as we offer a full range of modalities for people to use is the capacity to change on the fly. I'm going to keep that handy while we're getting ready to take the, what happened to? What happened to my Blackboard? Well, it's right here. Thought I had it open. Oh, I do have it open. Forgive me. Everybody still there?
Yes.
Yes, still here.
Yeah, I'm here.
Yeah.
All right, thanks. So James, you just joined us. So this is one reason why we don't work that screen all the time, because people will come and go, and it's easier for me to just update this. And so what I'll do is I'll take a snapshot as people join. And actually, I think James dropped and then rejoined. Yeah, that's what happened. Okay. Your mileage may vary. So let's get started. This is this is a course that earns you 3 credits, but it only meets twice a week, right? It only meets on Tuesdays and Thursdays. And the important thing to understand is that there's 75-minute sessions. Now, I used to try to grind the whole time, and I think this season is going to be distinctly different. So as I'm physically present in the classroom and also online in Zoom, if you split 75 minutes down the middle, you get basically 2 35-minute segments and then a 5-minute break in between. So we'll go about 30 to 35 minutes and then break for 5 or 10 minutes and then rejoin the session and then go another 30 to 35. I think this might be a better way of keeping people fresh. And that's the intent, is to make sure that as we cover this wide and broad, you know, there's a lot of deep, rich material in scientific computing applications. And in order to cover some topics more deeply, and in order to cover the broad range of interests that this course provides for all of our STEM degree students, right? If you're in the College of Science and Math, or even if you're not in the College of Science and Math, if you're engaging some science degrees in the other schools or colleges at our university, we basically cover a good bit of scientific method and tech, and how to get the most out of the science using the tech. And that means we're going to have to press pretty hard and strong, but if we go a full 75 minutes, people just get fuzzy after a point. It's too easy to tune out. Because we're a hybrid, we're going to offer different modes of content as well. You'll notice the syllabus. If you click this link, you can download an entire PDF version of the syllabus, but it's also carried on the screen in a web frame, so you can read it here. I call this out to you because I like to organize my course content in sort of a unique manner. I'd like the 3 links to be, when you see this, you'll only see the first module. So module 1 is M1, and it talks about scientific computing origins and essentials, right? And then the other modules that follow, as we finish each module, will turn up and allow access to the other modules when we get finished with each one. What's important to understand is this idea that computing is an active thing. In this case, instead of computing being a noun or a subject, I want you to think of science applications as a verb, right? So you're going to have to get your hands on it. We'll have to use different methods. For that reason, I'm going to ask you to share specifics about your own computing capacity and in the early parts of the course, and then we'll be using those. We will have virtual systems for you to log into remotely, so you can do some things online with another computing system instead of using your own technology. So you don't need a lot of technology. The official definition from the UVI course catalog is a bit dated. So it says students participating in this course must have acquired the skills of sending and receiving attached documents by email, and they must be familiar with web browser navigation. Students are expected to access class resources on the internet daily. It is strongly recommended that students have a computer with available access to the internet. Yeah, that original legacy description right before they made it a fully online course really doesn't capture that interest, right? Here's the part that's the most relevant. We're using the computer for scientific work. So this is where I'm going to ask computer science students to bear with me, because I'm going to get to the science. I'm going to get into the science side of this, right? And you might think, well, yeah, we have 2 science lab courses we have to take for our degree, biology, chemistry, or physics. And I'm going to say, yeah, but you use scientific methods to solve problems. And so an indelible part of the course isn't just using the tech, but it's also working the science aspect of it. The other piece of this is there's a lot of character-based, so it's going to smell and feel like some of this is old school, where you're working commands. You're not always using graphically rich computer applications. In some cases, you're entering commands from Linux terminal prompts. Everyone's here heard of Linux, yes?
Yes.
Okay. Yeah, Linux may be new to some people. And of course, after you create and generate the data, so basically entering, editing, and displaying, that's about data generation. And then you're capturing it in data tables. So we're going to be talking about databases quite a bit. So one thing we're going to deal with here is SQL-based data structures. And we're not going to do a full-blown thing, but we want you to understand the power of a relational database. So a good portion of the course revolves around the capture and organization and structuring of data. But then the other piece of the course, in the context of scientific and laboratory and research stuff, is that we're going to be using some pretty powerful tools to analyze the data once we have it. So you're going to run complex queries. You may have heard the term data mining or business analytics, right? That you're not just generating some quick results from the data, but you're also exploring some of the logical relationships, the patterns that manifest once you're analyzing that data. So, any questions so far? Does everyone see this? Would anyone be, would anyone?
I don't have any questions so far. I just want to say I was following along.
Okay. Is everyone familiar with what a Raspberry Pi is?
Yes.
Okay. Everybody here, do you know that you can hook all sorts of sensors to a Raspberry Pi to collect the data? Right? So hardware interfaces, one thing we're considering is kind of updating our course modules to include some hands-on stuff with sensors. And so we should know by early September, on the other side of Labor Day, whether or not we'll have access to some Raspberry Pis for use in the class. You're not supposed to have any previous programming experience or complete other CSC courses. Now, this is something that's a blessing and a curse. You will be asked to do some things verbatim, step by step, and to follow along with a demonstration that's been like recorded for posterity, right? It's really important that you repulse or shed your own habits. So especially if you're computer science students, you may have some familiar ways of approaching a task, a computing task, and that can actually be a problem. If you're working in Java and we're working in Python, there are some programming conventions that are problematic or can become problematic for some students because they're thinking in terms about the Java they learned. And so there's a different context, there's a different use for Python. That's an interpreted language, and we'll get more into that. But one thing we'd like to ask you to do is that even if you have a lot of experience in computer science and you're taking this course as an elective, that you would you'd wait to try the things that you know ordinarily and not just jump into it. I get calls from frantic students and they say, hey, I just can't get this to work. And I ask, did you follow the demo we captured at the YouTube? Did you follow the YouTube? And the answer I get is, why, yes. And then we share a screen like we're doing right now. And I have in the corner, guess what? The YouTube video. I'm just warning you. And then, you know, we follow along. It's like, okay, next step, do this, do that, do the other. And it's a little frustrating for, you know, computer science students who are ahead of the curve with their other coding classes when it's, oh man, what was I thinking? I had this, I don't use curly brackets here. You'll see what I mean when we get started. Is there anyone who's new as a student for my courses that are with us now? I know Courtney's been there before, Kevin, James, Milan. Oh, Meyer, was it ECS Scholars this summer? And Emmanuel, I think, right? Emmanuel, have we had a course together yet?
No, I only had a previous programming course with Dr. Francois last semester.
Okay. And then Meyer?
I had a class with you in the spring, last semester, last spring. It was the networking.
Oh, which class were you in last spring?
It was 243.
245?
243, I believe.
Oh, 243?
Yes.
Oh, digital. That's right. That's right. Okay. Digital communications. I'm sorry. Yeah, I might need another cup of coffee, I think. And now it's coming back. Okay. All right. Well, the one thing I wanted to share with you is how the grading methods work. A third of your grade is from module assessments. So as we complete the modules, the other thing I'd share with you is when you click into the module, the header itself is an active link. So it's not uncommon for students to click on the module and then they read this, which is the header. It's the cover page of the module. And yeah, it's useful information. It gives you a quick detail on what this is about, and it tells you which topics we're learning. It actually outlines each of the learning outcomes that you're expected to know or do. You know, what your reading assignments are. The other thing I'd share with you is that if you haven't had me for a course yet, the activities at the bottom here are very important because it'll spell out what's due and when. It'll tell you how many points it's worth. And here's the thing I need each of you to understand. The points that are listed here are points for your final grade for the course average as a whole. Let me repeat that again. The 5 points for this article summary If you blow that off and you say, yeah, I don't really like writing assignments, I'm not going to do it. 5 points are gone from your final average out of 100 points. 5 points are gone. Okay. So what's the highest score you can get? Anyone?
95.
95. 95 is it, right? The other thing too is that there's built-in opportunities to earn additional credit. So the other thing I want to tell you is that we do have exams. So a third of your grade, almost a third of your grade comes from module assessments, but you get to take the assessment more than once. After your first attempt, if you reconcile the errors on your first attempt, that's a quick, straightforward process. Can be kind of mechanical, but if you're paying attention to, oh, why did I get this item wrong? You quickly reconcile your errors and then you get a retake. You can retake the assessment. You can resubmit assignments, right? The hands-on part tends to be worth as much as the assessments. Now, in the first module, it's not worth quite as much, or that might be a mistake, and I need to change that to 5 points. But generally, the solutions come after the assignments and submissions, other assignments and submissions. So you want to follow the sequence. They're listed in before you get to the hands-on part, and especially before you get to the assessment. It's not uncommon for students to get hung up on some things and they say, well, I can resubmit those or turn those in later. And, but I'll just get this assessment out of the way. And a lot of times they may not do as well. The assignments and solution are designed to strengthen and provide experiences to use the concepts. So comprehension tends to be a lot stronger and a lot deeper when people complete the assignments, but especially the solution. Solutions are worth the same as far as the assessment, the module assessments. So almost a third of your grade comes from hands-on solutions, where you take the concepts and methods and you actually apply them. You actually use them to do something. And you submit artifacts of your experiences, and I take a look at what you created on your screen, right? Now, one thing I'd offer with you is that every now and then we get folks who try to help each other, and it's okay for students to help each other, but you don't ever want to borrow each other's work because there's criteria that's built into the solutions where if people are, for example, copying and pasting a graph on a chart, it's going to be pretty obvious that folks are copying and pasting between. But it's also going to be very obvious when folks are submitting authentic. And that's also helpful, especially when we're troubleshooting. So almost a third come from module assessments. Almost 1/3 of your grade comes from the hands-on. There is the same weight or value from exams. You have 2 exams, one midterm exam and a final exam. The midterm exam hits after this. We have 4 modules. The midterm hits after the second module is complete. So that's worth 10 points. And the final exam at the end is worth 20 points. So exams, midterm and final, are worth 30 points, nearly 33%, right? The remaining 10% is participation with assignments and other submissions, okay? And some of them are optional. Was there a question? Did anyone have a question?
No, I don't think I have a question. No.
Okay. Well, like some of the assignments I would call optional, meaning you don't really have to turn in an authentic, to validate authentic textbook and when I say authentic, I mean you either rented or, so if we go into the syllabus and then we click on this textbook is pretty amazing. Oh, I'm seeing that this doesn't, let me fix this right away. So I think when you pull this forward, if you ever catch a link that doesn't work right, let me know and we'll fix it right on the spot. Come on. Here we are. Here's the textbook. So Massachusetts Institute of Technology in Cambridge, they're kind of a powerhouse for engineering, science, and technology. It's a favorite haunt of mine. So I'm going to go ahead and duplicate this. So if you mouse over it, it'll put that same thing in there. All right, so now let's click on this link. Everybody with me?
Yes.
With you.
So when I say authentic proof that you have, I like electronic copies. I like to use textbooks that are low cost. And authentic means when you either pay to rent or to purchase, right? You can get into the table of contents and I can see elsewhere in the screen that, you know, your name is on the screen because you logged in. When you access this textbook from MIT Press, you create a login using your UVI email address. And in order to access it, you log in. So I'm going to see your name up there and this. Now you can get the same book online with Amazon. You can get it as a Kindle book, or in some cases, you may be able to get it as a PDF out on the internet. One of the most important things to understand about this book is that it comes with a huge collection of digital, scientific, and analytic tools. Humongous. And they run as a virtual machine. So what am I saying? You're creating another computing system within your personal technology on your laptop or your PC. If it turns out that your laptop or your PC are not up to the task, we can get you a laptop that you can sign out for the entire semester. But basically, when you rent or purchase this textbook, there's a website you can go to and you download their virtual machine and all the software with it. And it's really cool stuff. And it's really powerful stuff. I mean, put another way, it used to cost $750 to $1,000 just for the software some years ago. So 10 years ago, it was just not within reach of most people. So this is one reason I like working from this textbook. There are cases where selected assignments and the solutions require you to navigate specific tasks step by step in the textbook. If you don't have the textbook, it's going to show pretty quickly, and you're not going to be able to follow along, right? So this is just one of those caveats I want to be upfront with. Full disclosure, I don't want to surprise anybody after ad drop and they say, well, I was thinking about dropping this course, but you know, and I hope that little chime doesn't mean we lost somebody already. Oh no, we've lost somebody already. Hopefully they'll pop back in. So yes, when you create a login for access, there's additional materials you can download. Once again, it's a pre-configured and assembled virtual machine that runs in Linux. And it's actually really well designed. And so Was there a question? Oh, I see we have 7 again. So it looks like somebody dropped for a second and rejoined. I can tell you that this is the kind of textbook I would purchase and buy outright. I really don't like buying textbooks as a general rule. So one of the things I committed to when I became a professor, I wanted to be different in that I wasn't going to pick some $180 book that you'd only be able to buy hard copy in the bookstore. And then when you sold it back, it would be, you get $25, what, that's a couple of drinks and a few packs of ramen. And that's all you get back out of the resale of the textbook. This is the kind of book that would be worth keeping because there's a lot of methods on how to get stuff done in a science lab. So if you're a computer science student and you're going to be doing any kind of research or you're working any kind of solutions, there's a lot of scenarios in this textbook where it just tells you how, for example, this is how you work some Monte Carlo simulations. And so you're out on the internet and you Google, and there's 57 different responses on how to set up a Monte Carlo, and none of them are as cleanly described and plainly laid out as what's in here. Everybody hang on just a second. So, yeah, I hope this isn't an issue. If you need alternatives for textbook purchase, let me know. Any questions about the textbook?
Will I be able to pursue it on Amazon?
I'm pretty sure you can. So if I take a general introduction to effective, sometimes the Amazon links lead right back here for stuff like this. But the last time I checked, let's try it. And thank you for asking that, Courtney. So we'll go to Amazon. And there might be hard copies that are very, yeah, see the hardcover. So they offer it, but it's hardcover only on Amazon. It's $50, which might be less expensive than the bookstore. I know they do have this in the bookstore. I do know that it's not as expensive as some textbooks, but yeah, only 10 left in stock. So this is a pretty.
I would be willing to get it, but there's one problem. I have an Amazon order that's already supposed to be on the way, but it's still late.
Well, some Amazon orders arrive almost instantly and others take forever for some reason. It all depends on the reseller, right? So if you're buying this, plus when you're buying from Amazon, you may be buying from a third party. So if you're buying used, yeah.
It looks like I can't even get it delivered to my location.
Right. Which is why the electronic option is so attractive. I think being able to get this in a format that you can read on any portable technology and device is attractive, but there are second and third editions. You know how this is. So let's say you buy this and you decide you want to buy it instead of rent it. And I do this for a lot of my electronic copies. Then 6 months later, oh, hey, here's Tony Gaddis for the, getting started with Java or getting started with Python. Tony Gaddis, which you would have had in CSC 117 or 18 or 242. To me, that's a very well-written, very clean and well-organized textbook. If you need to learn a structured, a programming language like Java. Everybody's mileage varies. I will have some YouTube videos that I want you to watch, and one of them is one of the channels is promoted by a former employee of Google who did a lot of artificial intelligence and machine learning. It's really cool stuff. And he's also very easy to understand and follow. We have Dazi joining us. And, well, just for grins here. Whoop. Desi. Oh, I thought that said Dazi. Desi, welcome. Good afternoon. Oh, it changed to Ashwin Shagani. Is that a nickname for you? Should I call you Des?
It's no, don't worry about that. It's another name for me.
Okay. That's
I'm sorry for being late. I've been trying to figure out this whole thing in my UBI
no, that's okay.
account got locked out and Blackboard was giving me trouble.
No, that's okay. No problem.
Thanks.
So here's the syllabus, and we were just taking a look at the textbook. And one thing I'm starting to push a little more at the start of courses, right? So the course pacing, it's broke out into these modules, and there's 2 sections of the module. The first section is when you're learning about the concepts and methods, but then in the second half of the module, there's more hands-on where you're using it. And you know, some of the concepts, we're going to cover some of the concepts, but I am going to expect that this textbook in particular, if I have an explicit assignment for a given module, like this module here, and Ashwin, when you I don't know if you were with us earlier, I said when you get a module on your screen, remember to click the header. If you're familiar with the way I organize material, this material is kind of optional. It's for more depth and more exposure and more information about the topics and methods. So you can, you know, review, watch, and learn at your leisure, right? Not as critical. If it's in the references folder in each module, the expectation is this is the stuff that we need you to commit to memory, right? Don't be shy about digging in and reading and rereading. And if there are links, you know, play the links, get in there, that kind of thing. A lot of times with our module study guides, what you'll find are embedded links in the module study guide. And as you review those, if you run across a YouTube reference, you should click it, okay? And you should watch it. So anytime you see something in the references folder and the text is hyperlinked, make sure that you take a little time to investigate that. Any questions about our textbook or other stuff to this point?
No, seems I'm just gonna have to buy it online.
Yeah. But buying it online means you have immediate access to the additional materials for the course, including the virtual machine download. And that's important. So I can't stress enough. So in this module, what we'll learn about is, you know, the origins of scientific computing. And we want to relate the core computing competencies expected for STEM professionals. Right. So when we say STEM, we're talking about science, technology, engineering, and math. We want you to be able to identify, label. So if you're going to use technology, we want you to know the essentials for the tech, starting with hardware. And so we have some very basic stuff. For some of you in computer science, if that's your major, it's a little bit of a review. It has to do with something called the von Neumann model of computing. And then one of the most important things about scientific computing is that there are different classifications or different types of computing applications. And in order for you to work effectively, you really need to know how to make decisions about which tools or which applications are ideal for a given context. You may have largely numerical information. So a quick example of this would be to say that if most of your data is numerical, you're going to want to use a spreadsheet instead of a database. If you're using general purpose, if you're capturing general purpose data, and it's alphanumeric data as well as numerical, then you're going to want to work with something in the relational database arena and not so much spreadsheets. One of the biggest mistakes in scientific computing applications is that somebody has data they need to organize, and this is the first thing they do. They open up a spreadsheet, and then they start typing first name, last name, blah, 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 as if it were a data table. And an Excel spreadsheet or any spreadsheet is not. It is not a data table. It is a spreadsheet. And each of these containers, and we'll get into this more, you'll notice that the label changes. If you haven't had any formal introductions in the spreadsheet, there's some mind-blowing stuff that you can do. So we're going to go 0 to 60 in like 3 seconds flat. And in the first part of the class, you're going to go, oh, I knew that, I knew this, I knew that, yawn. Then we'll take our break after the 30-minute to 35-minute point. And then when we come back after the break, I'm going to say something like, okay, it's time to put your seat backs and your tray tables in the upright and locked position. You'll want to fasten your seat belts, right? So basically what we'll do is we'll take this common tool and turn it inside out so that you learn some inside tricks and tips for how to better utilize a spreadsheet. But the biggest challenge is knowing the best tool for the given need, proper tool for the proper job. You may have heard this before. And that's one thing that we're going to do in our first module and revisit that constantly. We want you to spend some quality time. And this is one of those banes of scientific computing. People go online, they get a YouTube video, they know about Raspberry Pis, they know about physics, they know about data sensors you can connect to the Raspberry Pi, and they start collecting like pH data or oxygen data or moisture data in the soil. And so they're capturing all this data. And the biggest challenge is that when you create custom scientific computing applications, you can't use a pre-configured application. You have to build your own application. We'll be doing a good bit of that in this course. We'll teach you how to build your own applications. And part of the contrast is, or part of the challenge is to give a little bit of thought to how to name the data, meaning how do you label the different data types? And so we're going to have some suggestions and some best practices to share with you. So yeah, this next learning objective is consistent with what we were just talking about. Assess and select a suitable scientific computing application to manage and analyze data using the context and criteria provided. So what we'll do is we'll have some scenarios. And in the assessment that you take in just a few days, see, by this time next week, you'll need to have proof that you've laid hold of the textbook, and we'll have an assignment that's due by Thursday of next week. So I'm going to ask you to do some things with your personal technology. By that same week on Saturday, we're going to ask you to turn in the one short writing assignment that we have for the course. It's just an article summary, and we'll talk more about that later. By the end of the month, Tuesday, 30 August, you'll need to set up the virtual machine that the Massachusetts Institute of Technology Press, MIT Press publishers, have provided for people who rent or purchase the textbook, right? So that's by 30 August. And what's going to happen is that you're going to have this digital tool shed full of resources. You have to be able to think about the logical conditions of a scientific computing scenario. So just as giving some time and thought to how you're going to name and organize the data, one of the tasks and skills we're going to share and learn is basically how to use some simple methods to break this down and make it easy. I like the direct flight. I don't like bouncing through. I don't like having to work through different methods just to get to a simple thing. But again, if you're a computer science student, I'm going to ask you to unlearn some stuff, right? If you don't organize the data for later analysis properly, your analysis is really difficult or just plain wrong. So what are we saying? We're saying that if you don't spend some quality time up front identifying selected criteria, the rest of it is really hard. And that's why we're going to take some time to explore those things in our first module. And then, of course, after you finish with your writing assignment and the first hands-on solution, you'll be able to present your outcomes, right? So you're going to post those online, and that's part of what we're scoring. Yes.
Does the written assignment have to be written, or can it be typed out on a Word document, notepad, or anything of the similarity?
Oh no, it can, any drafting tool of your choice is fine. If you want to, if you want to work in a word processor, that's fine.
Okay, thank you.
Now, I will tell you that when we get into the weeds on this one short writing assignment, there are some things that there's some guidance you're going to want to follow. And there's always one or two students every year, for some reason, they don't follow it and they copy and paste, and then they make quick work of it. And then the submission doesn't clear. So there are some very quick and easy ways to make writing painless, and that's what we're gonna investigate this year. I'm gonna get into more writing methods than I have in previous years, just to make this a painless process. So that's what we have ahead of us. I did not intend to engage much of the material from Module 1 today, but I did want to provide an overview. And yes, we are going to be working with virtual machines. Is there anyone that is in our class that has never really investigated the device manager?
What's that?
That's a great question. So the device manager in a Windows machine, and so here, this is obviously a Windows 10 machine. If I start typing file manager, go ahead. If you start typing file for File Explorer and you just open that up, usually it says this computer or my computer right here. But if you right click this, use the right mouse button or the right corner of your trackpad and select this, then a context menu comes up and you select manage. And that's going to come up, that's going to pull up the computer management console, the Microsoft Management Console, or MMC, Computer Management MMC. And this is going to give you all sorts of options to look under the hood of your personal computer. And one of the options is Device Manager. Now you can also access the Device Manager by going to your Start menu and starting to type Control Panel. And I mean, you see some of this stuff on my screen, but it might not look the same on yours. So you open up Control Panel, and for many people, the Control Panel looks like this. That's what the Control Panel looks like when you first get in here. And what you're going to do is select large icons. And then if you go into Administrative Tools, you'll see Computer Management. So you can get into the Computer Management console that way. Now I've got two of these open, but let's get back to this. If you select Device Manager, what you'll notice is that you'll see a list of hardware components, digital electronic components that your computer system uses. And I'm sorry, virtual machine. So here we were talking about the virtual machine. Computer scientists realized a long time ago that it would be much more practical to create virtual components of a computer so that the operating system could translate software calls without having to rework the software. And what am I saying? When you start up your computer, Windows takes an inventory of the actual physical devices in your computer system, and it creates virtual digital components and loads them into memory. So when you're reading and writing to your hard disk, you're actually doing it through a virtual hard disk in memory, which is similar to the actual physical hard drive. Now, why would they do that? Because every computer has different brands, different models of devices. You might have different kinds of memory modules, different video cards. The display has a different resolution. So your display adapter or video card might be integrated with the chip, or it might be dedicated because it's a gaming system. Everybody's is different. Some time ago, when hardware was rapidly evolving, computer engineers and computer scientists realized that the hardware of the average computer could accommodate more than one system. So they figured out a way to take this and turn it in, well, they took this idea of virtualizing the physical components, and they did that on steroids, so to speak. They built whole virtual computing systems, it's called a virtual machine, right? So inside my physical laptop, I can run 3 or 4 virtual machines simultaneously. So
Question, so you're talking about running different like OSs?
Yes.
Okay.
Yeah, exactly. I'm running a Windows host, so my laptop is considered the host. But when I create a virtual machine, inside my Windows laptop, I'm also running a Linux computing system. I'm running a replica of a Raspberry Pi. You can download a virtual machine of a Raspberry Pi. And so you can actually work with a Raspberry Pi without actually owning a Raspberry Pi. You can run it as a virtual machine. I can run a Mac as a virtual machine. I can run my Android smartphone or my Android tablet as a virtual machine. And I can run multiples of those. If I have enough CPU and I have enough RAM, I can juggle multiples of those, and they'll all run at the same time doing different things. It's pretty cool stuff. But more importantly, it's very powerful when you have a variety of interests. Now, let's just say you want to investigate the science of a thing and you're on a budget. Well, this technology has come so far that, you know, if you have an average laptop or an average desktop, most people underutilize their personal technology dramatically. It is almost a crime how much hardware is unused on most systems. And yet the average consumer would beg to differ. They would argue, they'd say, oh, Professor Kentop, that's an exaggeration because you know, my smartphone is really slow. Well, what they've done is they've opened up applications and then never really closed them. They were multitasking. Does everybody understand what I'm talking about?
Yes.
Yeah, so you have like 26 tabs on your browser, right? And each of those are separate websites with features and functionality. So you have 26 web applications running in 26 tabs, and then you have all of these other apps that are running down here, and your poor system is chock full of semi-active applications, and it's kind of bogged down. And the trick is to understand our habits, or at least the bad ones. And then as you're working with science interests, right, you just manage those quickly and efficiently. You close all those apps out and close out all the different web browser tabs, and now you can run virtual machines. Now you can run several virtual machines at the same time.
Does it have to do with the amount of cores in the computer is made of?
Yes, that's a great question. So if I take this taskbar and I go to Task Manager, and then I look at the Performance, right, tab of my Task Manager, it'll tell me the number of cores my CPU has if I select cores. So I have a single chip in a socket, but that chip has 2 processor cores, which are like 2 different CPUs.
I thought that was called a build.
Well, yeah, there's a lot of terminology that's bantied about, but the builds, depending on the context.
My bad, a thread.
Threads, okay, so yeah, all right. Let's talk about this just a minute. So you have cores, and those are physical cores. So on the whole chip, right, the chip itself is large, and then inside there are smaller sections that are each processors, and those are called cores. So you have two CPUs technically on this system. Now, those can be threaded or hyper-threaded, virtualized, and if virtualization is enabled, that allows you to have 4 logical processors. It gets back to what we were just showing you with this. So if I look at the computer and I look here, it shows that I have a specific type of motherboard for my system. But if I come down to processors, now you see that I have 4 Intel processors. Well, those aren't 4 real processors. They've been the 2 physical processors have been virtualized, and the threads of the memory threads that are used to control those are integrated, so that basically with virtualization enabled and with hyper-threading, You can double. Now, sometimes cores are designed so that when they're hyper-threaded, it's not just 2 times, it's three times the logical processors or 4 times logical processors. It all depends on the physical design of the hardware components. So when virtualization is enabled, we most commonly see that when threading is turned on, it usually means double, right? So I have 2 physical cores, but the operating Windows actually sees 4 CPUs. That means I can create virtual machines and give one of those virtual processors or logical processors to a Linux machine over here. I can take the second logical processor and give it to you know, a Mac clone. So you can go out there and you can download the Mac OS as a bootleg clone out on the dark web. I would urge caution about your source and where you get those when you do that. But yeah, so
I'm sorry, I just got that source because I'm studying also from CompT at the same time.
yeah,
Yeah, so I'm taking the online A+ course.
uh-huh.
So so they
I-
were just talking about that stuff. But I totally understand what you're saying about like take yours advice and the education that you're teaching me.
Right. Well, the thing is, some of my statements will be oversimplifications of the context. So the main thing to understand is that Intel has a certain way of designing their computer engineers design the chips in a certain manner. But IBM, for example, or Cray is another example, or an even better example would be graphics. The folks that do the graphics cards, they design the GPUs. In some cases, the physical cores are enhanced so that when it's virtualized, it can support more than just 2 times the number of processors. It can be 3 or 4 times. And that's dramatic. I mean, if you've ever seen that, it's like, okay, this is a server CPU. And by the time it's hyper-threaded, 4 physical cores becomes 16 virtual machines. And when I said you can take this core and use it for that Linux machine, it's not quite that simple. The hypervisor, the software that's used to create the virtual machine is called a hypervisor, and the design of the hypervisor will parse out these resources in a certain manner. The thing to understand at the core of it is if you don't have the physical resources, you can't virtualize. Like if you have how much memory do I have? I have 12 gigs of RAM on this laptop. I cannot create 64 gigabytes worth of virtualized RAM and run them simultaneously. So I couldn't have like 5 different virtual machines and they're 4 gigs of RAM each, and that makes 20 gigs of virtual RAM, and then I'm going to load all 5 of those virtual machines, but my physical machine itself only has 12 gigs, right? So I only have 12 gigs. That's a problem.
What does the committed mean right there when it says 5.3 out of 23.7 gigabytes?
So there's a thing called virtual memory. It's page file memory. So this is stuff that we get into in the operating systems course quite a bit. You have physical RAM memory, and that's usually pretty costly. And when you have so many applications loaded, you run low on memory. So your CPU swaps out pages of RAM memory to the fastest part of the hard disk, to the a special section of the hard disk that's more accessible in real time, because the sectors of the disk are near the front of the drive heads. So it's quicker access, right? And that page file memory, it's called, or virtual memory.
I'm in the middle of class. Yeah. But, heads up.
Hello, how is everyone?
You guys
That,
were supposed to have class, hey?
well,
Uh,
we were actually about to wrap it up.
Don't worry, I'm gonna be done in a few minutes.
So we have this hybrid kind of memory. It's temporary storage. Think of disk-based memory pages as a temporary store of what's loaded into RAM. So the page file, I have a fixed virtual memory. When I configured my laptop, I used some inside tricks to double the performance of this thing. So if I go in here and I go into my properties of the laptop, and then I go into advanced system settings.
Dr. Kentop, I have to step away from my computer for a moment.
Yes, well, we were about to wrap up. I was just going to show this one thing and then sign off, but yes, I understand. Go ahead. In the system properties, it normally shows computer name, but if you go to advanced and then go to performance under settings, there's a second advanced option. You can set up the virtual memory for use on the hard disk. It's a way of supercharging the RAM, okay? And so I have 12 gigs of RAM, but then I also have dedicated or devoted virtual memory that I set manually instead of allowing Windows to automatically adjust. So I did some things to optimize the hard disk, and then I set up the same minimum and maximum size. We're going to go into this, by the way. And what that does is it doubles the amount of memory you can commit to tasks. So you were probably asking, like, okay, how is it that you have more that you can commit than the physical memory that's present? So I have 12 gigs of actual physical RAM memory, but then I also have page file virtual memory that I use to swap out when the RAM gets full. And that doubles my capacity, so I have nearly 24 gigs of memory available. With all of the things that I'm doing now, I have multiple tabs in Edge, I have File Explorer open, I have Paint open, where I captured the class list, I'm running Zoom, I'm recording this session as we do this. So up here, there's a recording that's active, I have a spreadsheet open, I've got all this system utility stuff open. Each of those is consuming 5.3 gigabytes of active RAM, okay? So the 5.3 is active. If I actually go to the processes, I can see if I click on memory usage, it'll tell me how many megabytes of memory are being taken up actively while these software applications are active. Does that answer your question?
Mostly. So I feel like I'll understand it more as we go through the whole subjects.
Oh yeah, absolutely. We'll break a lot of this down for you, and there will be plenty of time to explore deeper. And that's half the fun of this class, is figuring out how to get more out of your computing hardware, and that's really important when you're working science, when you're using it to solve scientific problems. Yeah. All right. So I'm going to go ahead and stop where we are right now. Does anyone have any questions before we close?
What will the recordings be posted?
I'm going to try to post the recordings within 24 hours of the class, most often.
On Blackboard? Or would you be doing it like how you did last semester on the YouTube channel?
Well, it'll be in Blackboard. That's a great question. And if you look in the content, if you look in the resources, there'll be a class recordings folder. So, and that's where you're going to see, you'll see a folder for fall 2022, right? So I've left these in place because there were some sessions that we did last year, and it's just good to have on tap. I have a legacy session that I did years ago about creating a database to track turtle migrations or something like that. Sea turtles, right? So for folks in marine science, it was like, hey, here's how you build a sea turtle database. And I did it from scratch in like 30 minutes. And that's an older recording. But you'll see in the class recordings, I'll have a fall 2022 session, and that's where our class recordings will be. That's a great question. Thank you for asking that. Any other questions?
I don't think I was here for this, but what do we need?
What do you need for?
Yeah, like the whole class, like you said, textbook. Do we need a PC or can we use a Mac?
You can use a Mac, and there are some things that you can, well, Macs are a special case, and I'm really glad you brought that up. Some of the software runs well on certain Macs and not so well on others. In particular, if you have a new Mac with the new processor, for some reason, the virtual machine doesn't work as well. But what you can do is use the Mac and use the Mac equivalents. See, a Mac is a Linux. It's a Linux-like system. Now, that I'm saying that just to keep things simple. Mac fans, and especially computer engineers and computer scientists who work for Apple computers, would argue, no, it's like Unix. It's not Linux. Yeah, no. But if you have a Mac, you're good to go, and you should be able to run the virtual machine. If you can't, you can use your Mac to connect to a virtual machine I host. So I can run virtual machines you can connect to using your Mac, or you can sign out a laptop from the library for the semester, Windows machine. Does that answer?
Got you.
Yep.
No, yeah, because I have a PC also. I mean, like, I can also use that.
Right. And if you go to the textbook website and you rent the textbook for just the length of the semester, right, then you get access to the software, the computing software, and the virtual machine they built. It's pre-configured. It's pretty impressive.
Is this textbook only virtual? It's not, we can't get a physical copy?
You can get a physical copy. There are physical copies in the bookstore, and there are physical copies you can order new or used through Amazon.
Got you.
But your mileage may vary.
Of course.
I have a physical copy, but I also have an electronic login because I like using both.
Mhm.
And the thing that I really enjoy more than anything is that once you have a login with your UVI email address, you set that up, you get access to additional resources like that virtual machine. So that's where you can follow what's in the book on screen, and it's a one-to-one comparison. So they did a really good job of setting it up. And then a year after they put it out, when they first published the book, it got all screwed up because the versions changed. So then they came out with a second version and a third version of the virtual machine. And one of the things that we encounter each year is that sometimes, a new update screws it up, and certain things don't work like they're supposed to, but we can usually find the problem and resolve it as long as folks capture the screen and give us a heads up. It's actually part of the challenge that you face when you're learning to use scientific computing applications. The same process and troubleshooting you're going to work through, we're going to do in class, just getting your stuff working. So it is basically the same, you know, you follow the same challenges getting started to walk through the examples in the course as you would in a research lab. Oh, I can't get my Python to run this script. What's wrong with this script? And it's some goofy technical, but often very minor detail. So hands-on. The primary interest of this course is to make it hands-on. That's why a third of your grade comes from the hands-on solutions. I hope
Okay.
I hope that
So
answers.
we just need a computer and just the textbook.
Yes.
And so if we have a physical Raspberry Pi, would you recommend that or no?
Oh, if you have a physical Raspberry Pi,
Yeah.
I would try some of the stuff that for the assignments on that Pi. In fact, last year we had 2 students that did not have a serviceable laptop, and they had an older Mac, but it wasn't really working right. So I brought 2 Raspberry Pis over to St. Thomas, and we issued those as kits, and they hooked them up to their flat screen TV and used a cordless mouse and a keyboard, and away they went. And most of the assignments that we had in class, they could do 1-for-1 with the Raspberry Pi. The latest Raspberry Pis allow you to load the same version of Linux that we have in the MIT virtual machine. So the flavor of Linux that's used to build this virtual machine will also, there's a distribution that's also custom compiled to run well on a Raspberry Pi. You don't have to use the native OS on a Pi. You can run Linux full scale. So yeah, no, whether you want to do something in your Mac or you want to do it with the Raspberry Pi, if you remind me and you work the activity and claim, hey, I did this on my Raspberry Pi or my Mac, I'll post additional credit for you. Because sometimes people try it and they can't get it to work, and using different tools and getting the same results, that deserves extra credit. So I'm glad you brought that up. All right, well, unless there are other questions, I'm going to sign off for now. I look forward to our class on Thursday. Remember, we are going to break the class in half and take a short break in the middle of the class. So if you're joining us in progress at the 30 to 35-minute mark and it seems like, hey, what's going on? Nobody's really doing anything. It's not that we've concluded the class, it's just that we're taking a break. And I'll usually post something in chat, except that if you join after the chat's been posted, you won't see it in the chat on Blackboard. Does everybody understand what I'm saying? So you might queue up your mic and go, hey, hello, is anybody there?
Wait, can you repeat that again? Sorry.
When we meet on Thursday, we will take a break at the halfway point. And if you join us in progress, even if I post something in the chat that says, hey, we'll resume at 3:45, right? If you join after I post it in chat to participants, you won't see it because you joined after it was posted. So don't be afraid to unmute your mic or ask others, hey, what's going on? Nothing's happening on screen. You know, did we conclude the class or is this a break? So I want you to be aware that that's going to be a thing.
Will like your screen still be open?
Yeah.
Or is it going to say like it's paused?
You know, that's a good point. I guess what I ought to have is a splash screen that says break ends. Yeah, you know what? You're right. That's a better way to, thank you. That's a better way to do this. I will open up a window and I'll post in big letters, right? I'll do something with PowerPoint, big letters that says break is over at 3:45. Please stand by or whatever.
Yeah, like class will resume at blah, blah, blah.
Yeah. I'll have a placeholder to cue people in. That should work. Yeah, that should work. All right. Well, we'll see you on Thursday. I look forward to a productive and interesting fall 2022. Thank you for your interest in scientific computing applications. Bye-bye for now.
Thank you.
All right, see you next time.
Oh.